Hi, Lawrence from Juniper Networks Education Services here. If you're interested in learning more about filter-based forwarding with a flow-based device, be sure to check out our Advanced Junos Security course. It's also covered on the Juniper Networks Certified Professional Security exam, so you'll want to know it if you're pursuing a JNC IPsec. For full details on the course, just visit juniper.net/courses and search for the title. Now let's get to your Learning Byte.
Welcome to Juniper Learning Bytes. My name is Zach Gibbs, and I'm a content developer within Education Services inside of Juniper Networks. And today we will be discussing the filter-based forwarding with a flow-based device Learning Byte. Alright, so at this point you might be asking yourself, what is filter-based forwarding? Well, to discuss that, we first have to discuss what is normal forwarding. By default, most devices forward traffic based on the traffic's destination address. That's what's in the IP header. They look at that destination address and then they forward it based on the routing information that layer 3 device has for that destination address. Well, with filter-based forwarding, this allows us to forward traffic based on other parameters such as the source address, source port, destination port, or whatever else we want to. So, for example, we have two servers here, server 1, server 2. We can forward traffic out one interface of the router and forward traffic out another interface of the router. Alright, so along with filter-based forwarding, there's another topic we need to discuss. Asymmetric traffic with a flow-based device. Now, what is asymmetric traffic? Well, traffic leaves the interface of a device, and then the return traffic comes back on a different interface. Now, this could be a different device it comes back on as well, so there's many different scenarios with asymmetric traffic, but suffice it to say that that return traffic is dropped. And with a flow-based device like an SRX Series device, the reason behind that a lot of times is because the interface that the traffic leaves on is not the same interface that it comes back on, and those two interfaces are in different zones. Now, if those two interfaces are in the same zone, the SRX Series device will accept it. So that's very important to remember. And I'm not going to go into a lot of detail here because there's another Learning Byte that covers this, the asymmetric traffic with a flow-based device Learning Byte. So if you're interested in more detail about that, please check out that other Learning Byte. Alright, so let's talk about configuring filter-based forwarding. First, we need to create a match filter. That's a firewall filter that's going to match specific traffic. Then we need to send that specific traffic to a routing instance. Then we got to create that routing instance. It's going to be an instant type forwarding, and this is going to create a new routing table for the new path. And finally, we have to create a rib group. This is going to share interface routes between the routing instances, usually the main routing instance with the filter-based forwarding routing instance. This is going to make next hops resolvable, and we'll see that in the configuration. And then optionally, we can apply an import policy to restrict which routes go into that new instance. Now, this is important for a couple different reasons. First of all, if we don't do it, it's just going to take all the interface routes that are in the main routing instance and just dump them all into the filter-based forwarding routing instance. Well, that's going to be some extra clutter we don't need. It's unnecessary. And then also, every route that we copy uses more memory on the device that we're doing this on. We're going to be using some SRX Series devices. And so, to me, it's going to be much better if we don't do that. And also, we do have the possibility of getting routes in there we don't want to get in there. And then something could go wrong where we're forwarding out wrong interfaces. Just not a good idea to have routes in a routing instance that you don't need. Alright, so let's look at an example here. So we have server 1, server 2. We have SRX1 here, the blue device that we got right here. That's going to be an SRX Series device. They're connected as server 1 with Gigi004, server 2 Gigi005. And then we have two paths. We have a path through ISP A, which is Gigi001, then ISP B, which is Gigi002. And there's a default route setup that's going to send traffic by default through ISP-B. And so what we have here is we want server 1 to take the ISP-A path, so the path through ISP-A, and then server 2 is just going to use that default route and take the path through ISP-B to reach this SCP server in the cloud. So this could be a scenario where we have a couple servers, they're both doing backups through SCP to a cloud-based server, be it configuration, syslog files, or whatever. They're just set to just continually just upload those files to that cloud-based SCP server. And so in the scenario, we want to use our backup link. It's just sitting there, and maybe our primary link is getting somewhat saturated with other users, things like that. So we want to be able to use that backup link through ISP-A. And so we can accomplish this with filter-based forwarding. And so let's jump to the CLI now.
2.
All right, here's the CLI for server 1. Let's just initiate some traffic to see what path it takes. This is SRX1. Looking at this, we can see that we look at Gigi002, we see it's going out. The far right side is the output packets. And so we can see it's going out Gigi002, and then the input packets, which is right here, I'm just highlighting out to the input packets, it's coming back in on Gigi002. It's not what we want, but we're going to fix that. So we'll kill that transfer, and we'll just take a quick look at server 2 as well to see which interface we're using as we do the transfer. It's the same thing. Gigi002 for output and input. So the outgoing traffic, the return traffic. And that's what we want for server 2, but we're going to change that with server 1. So let's jump into configuration mode. So let's configure that routing instance. We're going to call this FBF for the routing instance. And we need to configure some routing information. Typically it's going to be just a default static route. Next hop is going to be the next hop for ISP-A. That's going to be 10.50.50.2. And then we can take a look at this routing instance. And you think it might be, okay, all set. And it's not, because right now, since we don't have the instance type set, it's set as a non-forwarding routing instance. And that means it's not going to forward anything out of it. And so we do need to set that as an instance type forwarding. And we see now we have the routing instance set up correctly. All right, since we have that, let's jump to the firewall filter. Let's call this FBS filter term 1. We're going to set from source address, we're going to set the source address of server 1, which is 192.168.0.100. We're going to say send to a routing instance. We're going to call that the FBF routing instance. We're going to reference that. And then we can do one more thing. We can set up a counter. And this will be helpful to allow us to see that if traffic's actually hitting the firewall filter term. And you think you might be done here, but there's a little bit more we need to do. With just this term, we set that on the Gigi004 interface as input. It's going to match traffic for that server address, sourced from that server address. It's going to send it to the routing instance, but any other traffic, it'll drop because firewall filters have an implicit discard at the end. If traffic doesn't match, it's going to get dropped. And in our scenario, that's not a big deal because we only have that one host on that LAN, connecting in on Gigi004. But in a production environment, more than likely you're going to have more than one host. So we want to set another term that just accepts all other traffic here. And then we want to set that on the interface as an input filter to the Gigi004 interface. And that's all we need to do with the firewall filter. Alright, so next we want to configure the rib groups. I'll call this just FBF for the actual rib group name. We're going to do an import rib. We're going to specify the inet.0 table. That's the master routing instance. And then we'll specify the fbf.inet.0. And what this does is this will copy routes from the inet.0 routing table and put them in the fbf.inet.0 routing table. And then we need to set the interface routes to tell us, we need to tell the router to put the interface routes in that rib group that we just created. And then we can look at this, and there's one other thing I want to do here. I want to do that import policy for the rib group. We haven't created this policy yet, so we'll do this next. Just have to make sure we spell it all correctly, and that'll restrict which routes can go in there. And what we want to do here with this import policy, we want to set from the GIGI001 interface, set to rib fbf.inet0, then we're going to accept that. And so what's happening here is we're saying, it's from interface GIGI001, we're sending it to rib fbf.inet.0, accept that. And so with how this import policy as is, we're going to accept the interface route for GIGI001, and also we're going to accept everything else. So it's not really doing much for us at the moment, so we do have to set a second term. Reject, to reject all the other routes. Alright, so at this point we should just be able to commit the configuration, and let's test out our transfers here. This is server 1, and this is not a good sign. We're not even getting the password prompt. Let's jump back to the SRX Series device. Let's look at the firewall filter. Okay, so we got some packets here. See if it's incrementing. It is incrementing, so we are hitting that. We're hitting that filter, and it's getting sent to the routing instance. Well, let's check out the routing instance. Let's just look at the routes. Okay, things look good here. We got the main routing instance, and then we have the filter-based forwarding routing instance too. We just have that default route pointing towards ISP A, and then we have that interface route for GIGI001. So things look great there. Import policy is working great. We're only getting those two routes in there. That's all we want. The default route in fbf.inet.0 is resolvable through GIGI001 because we have that interface route in there. So everything's looking good. So let's go back and let's cancel that transfer, and let's do this transfer again here, and let's take a look to see, maybe this will give us some ideas. Looking at the other transfer, I have a feeling it will. Alright, so we can see, we saw this beforehand, but this is just a little review, that with GIGI002, we got the output and input, so the traffic's being sent out GIGI002 and coming back on GIGI002. So we can deduce from that when server 1 over here sends the packet, gets forwarded out GIGI001, that it's coming back on GIGI002. And if we jump back to the server 1 again, try that transfer again, go back to SRX1, look at the actual flow table, we can see that we are trying to use, we're expecting the traffic to come back on GIGI001. Well, we know that that SCP server is sending it back on GIGI002. That's a problem, all right. So what can we do about that? Well, if you remember earlier in the discussion, we talked about security zones. We talked about those two interfaces need to be in the same security zone because we have asymmetric traffic here. And looking at the security zone, Internet and Internet 2, those two interfaces, GIGI001 and GIGI002, are in separate security zones. So I bet if we remove the one security zone, or remove the interface from the security zone, and put GIGI002 in the same security zone, put GIGI001 and GIGI002 in the same security zone, I would bet to say, kill that transfer so we don't have problems. Let's kill this other transfer too. I would bet to say that that might resolve our problem. Let's see. Hey, this is a good sign. We got a password prompt. And the file is transferring. Let's look at the path it's taking. Alright, so, hey, I like what I'm seeing here. Look at this, GIGI001, the output on the far right here, we're seeing output for GIGI001. And then we look at GIGI002, the input is coming in on GIGI002. That's exactly what we want to see. That's perfect. Alright, so that brings us to the end of this learning byte. In this learning byte, we discussed what filter-based forwarding is. We demonstrated how to configure filter-based forwarding on an SRX Series device and did a little bit of troubleshooting there as well. So that's the end, and as always, thanks for watching.
Visit the Juniper Education Services website to learn more about courses. View our full range of classroom, online, and e-learning courses. Learning paths, industry segment and technology-specific training paths. Juniper Networks Certification Program, the ultimate demonstration of your competence. And the training community, from forums to social media. Join the discussion.